Imagine looking at a world so close to the Sun that it seemed forever locked in its fiery glare. For centuries, Mercury was nothing more than a shimmering mystery difficult to observe and nearly impossible to study. Without spacecraft, we barely knew what this tiny world looked like. In fact, until 2011, half of Mercury's surface remained unseen by human eyes. That changed with NASA's Messenger mission. Originally designed to last just 1 year in orbit, it surprised everyone by surviving for 4 from 2011 to 2015. During that time, it returned over 200,000 images, scanned the planet for minerals, probed its atmosphere, or rather its exosphere, and mapped its magnetic field. Today, let's retrace Messenger's remarkable journey and uncover the strange truths it revealed. We'll explore Mercury's unusual orbit, its offset magnetic field, its comet-like tail, the discovery of water ice in eternal shadows, and the scars of ancient volcanoes and colossal impacts. One of the most fascinating things about Mercury is the way it spins. Unlike our moon, Mercury is not tidally locked to the Sun. Instead, it's trapped in a rare 3-2 resonance. That means for every 2 orbits around the Sun, Mercury spins on its axis exactly 3 times. This creates a peculiar coincidence. Its sidereal day, the time it takes to rotate, once lasts 59 Earth days. Its synodic period, the time between alignments with Earth, is 116 days, exactly twice as long. From Earth, early astronomers always saw the same face during prime viewing, which led them to believe Mercury never rotated at all. For generations, Mercury was thought to keep one side forever scorched and the other side frozen in darkness. It wasn't until the 1960s, with radar observations, that we discovered the truth: Mercury was turning just more slowly than expected. Mariner 10 later visited in the 1970s, but its flybys were locked into an orbit that showed the same hemisphere each time. Half the planet remained unknown. This mystery set the stage for Messenger. To truly understand Mercury, we needed an orbiter, one that could patiently follow the planet through its days and nights. In 2011, after years of planning, Messenger finally achieved that goal, entering orbit and beginning one of the most ambitious explorations of the inner solar system. On board Messenger were sophisticated instruments, including a magnetometer to measure Mercury's magnetic field. Why was this so important? Because Mercury, unlike Venus and Mars, actually has one. Mercury's magnetic field is weak, about 1% as strong as Earth's, but its very existence was puzzling. To generate a magnetic field, a planet needs a molten core and a dynamo effect, usually powered by rotation. Earth has this, thanks to its rapid spin and the tidal stirring from our moon. Mercury, however, rotates slowly and has no moon at all. By all logic, its core should have frozen long ago. So why does it still have a magnetic field? Messenger revealed that Mercury's highly eccentric orbit plays a crucial role. As the planet swings closer to and farther from the Sun, the gravitational pull varies, flexing the planet and generating heat. That heat keeps the metallic core partly molten, sustaining the dynamo. But there was another surprise: the field is offset, shifted northward by about 20% of Mercury's radius. Imagine if Earth's magnetic field was so lopsided our compasses would point in strange directions depending on where we stood. The reason for this offset remains a mystery. Being so close to the Sun, Mercury's magnetosphere is also unusual. Solar wind pressure is far stronger here than at Earth, compressing the protective bubble tightly against the surface. As a result, Mercury's magnetosphere is turbulent and dynamic. Messenger detected reconnection events, moments when magnetic field lines snap and reform, happening 100 times more often than on Earth. These events allow solar wind particles to penetrate, creating plasma flows and bursts of energetic electrons. Thousands of such bursts were recorded, concentrated strangely in the northern hemisphere. Even today, scientists are still trying to unravel why. What we do know is that Mercury's magnetic environment is unlike any other in the solar system. It is a fragile shield, constantly battered by the sun, yet still resilient enough to survive. Unlike Earth, Mercury does not have a thick, breathable atmosphere. Instead, it possesses an exosphere, an incredibly thin layer where particles rarely collide. You might think such a barren world would be depleted of volatile elements, but MESSENGER revealed the opposite. The surface is surprisingly rich in substances like potassium, magnesium, sulfur, sodium, and chlorine, far more than scientists expected, and much higher than levels found on our moon. This discovery shattered long-held theories that the inner planets should have lost most of their volatiles during formation. These materials don't stay fixed on the surface. Bombarded by radiation, many are ejected into the exosphere. Potassium, for example, is more abundant in the northern hemisphere than at the equator, likely because equatorial regions are hotter and have already lost much of their supply. The exosphere is anything but stable. Solar wind particles sweep away atoms, while the pressure of sunlight pushes them outward into space. Yet the exosphere persists replenished constantly from the surface below. MESSENGER also revealed contributions from beyond Mercury. Hydrogen and helium elements absent from the crust were detected in the exosphere delivered directly by the solar wind. These particles temporarily linger before escaping into space. Perhaps the most striking revelation was Mercury's comet-like tail. Sodium ions, illuminated by sunlight, stream away behind the planet, creating a faint yellow glow. If you stood on Mercury's night side and looked up, you might see the sky tinged with that soft light, as if the planet itself were becoming a comet. This tail even varies with the seasons of Mercury's eccentric orbit brightening when the planet is at certain distances from the Sun. Such behaviour had never been seen on a rocky planet before. MESSENGER's findings reminded us that even the smallest planet in the solar system can behave in dramatic, unexpected ways. One of the most shocking discoveries was the presence of water. On a planet where daytime temperatures soar above 400 degrees Celsius, how could ice possibly exist? The answer lies at the poles. Some craters near Mercury's poles are permanently shadowed, never receiving direct sunlight. Within these eternal night zones, conditions are cold enough for water ice to survive. Radar observations from Earth had hinted at reflective regions in the 1990s, but MESSENGER confirmed them. Beneath layers of insulating dust, vast deposits of ice were found. Estimates suggest about 250 kilograms of water ice may be trapped there. Compared to Earth's reserves, this is small, but for Mercury, it is monumental. For any future explorers, these frozen stores could be a lifeline, providing water and even fuel if split into hydrogen and oxygen. Even here, in one of the harshest environments in the solar system, water finds a way to endure. MESSENGER also uncovered a landscape shaped by ancient forces. One of the most unique features is the presence of hollows, shallow depressions scattered across the surface. Unlike craters caused by impacts, hollows are thought to form when volatile materials vaporize, leaving behind voids. They are among the youngest geological features, proof that Mercury is still changing today. There is also evidence of past volcanism. Some craters have been completely filled with lava flows, and vast plains of once molten rock stretch across the surface. Though Mercury is not volcanically active today, billions of years ago it may have resembled early Earth dotted with shield and compound volcanoes. Mercury's most dramatic feature, however, is the Caloris Basin. This impact structure is 1,600 kilometres wide, among the largest in the solar system. It was likely formed by a 100-kilometre wide asteroid striking Mercury with unimaginable force. The result was global, a ring of mountains 2 kilometres high, radiating troughs that extend outward, and on the opposite side of the planet, a bizarre region of jumbled terrain where shockwaves converged. Adding to this are long scarps, cliff-like structures that crisscross the planet. These scarps are evidence that Mercury is cooling and contracting. Since its formation, the planet has shrunk in diameter by over 14 kilometres. It is as if the planet itself is slowly folding inward on its own core. Through Messenger's eyes, Mercury transformed from a barren rock into a world of scars, ice, and strange geology, an active, evolving planet despite its small size. By the time Messenger's mission ended in 2015, it had revolutionised our understanding of Mercury. What was once a faint point of light near the Sun became a richly detailed world full of surprises. We now know that Mercury has an offset magnetic field, a dynamic exosphere, volatile, rich crust-water ice, hidden in polar shadows, and geological features shaped by both volcanism and catastrophic impacts. These discoveries reshaped theories of how the solar system formed and evolved, and yet despite its success, Messenger remains one of NASA's most underappreciated missions. Perhaps the next chapter belongs to ESA's Bepi Colombo, currently on its journey to Mercury. By 2025, it will arrive and build upon the legacy Messenger left behind. Messenger showed us that even the smallest planet has grand stories to tell. As we reflect on Messenger's journey, it's worth asking what mysteries still remain. Could Bepi Colombo uncover why Mercury's magnetic field is offset or explain the origin of its strange hollows? One thing is certain, Mercury will continue to surprise us. If you've enjoyed this exploration, let's keep the journey going together. On Cosmic Compass, we dive into the hidden corners of our solar system and beyond, uncovering the stories that shape our cosmic neighbourhood. You can check out our other videos, including one where we explain why Mercury is such a difficult planet to reach in the first place. And if you'd like to support the channel, subscribing and sharing helps more than you might think. The universe is vast, and there's always more to discover. Until next time, let's keep looking up and let's keep exploring.